Hello and welcome to the Amazon Web Services webcast. Today's presentation is AWS Lambda, event-driven code for devices in the cloud. My name is Tim Wagner. I'm the General Manager for AWS Lambda, and I'll be talking today about Lambda's event-driven code support for both devices and the cloud. And before we talk about some of the newer functionality that we've just delivered, I want to take a step back and talk about what we launched last November at reInvent. What we brought to market then was support for something we call Lambda Functions, the stateless, request-driven code execution in the cloud. Lambda Functions are a mechanism to encapsulate code and then run it in the easiest possible way, without infrastructure, without scalability challenges. And then we also made it possible to hook that code up to other AWS services. For example, Amazon S3 buckets, so that every time you do a put to the bucket, the code can run in response. To Amazon DynamoDB tables to capture changes that are happening to databases, to Amazon Kinesis streams to process records that are happening through a stream. And this makes it easy to transform data as it reaches the cloud, to perform data-driven analyses, audits, and notifications, and also to kick off different kinds of workflows. And we'll take a look at a bunch of different examples of these. First, let's talk about integration with Amazon S3. So let's take a simple example here. Imagine that you want to thumbnail images. And instead of standing up kind of a fleet of servers and building a lot of infrastructure and complexity to do that, you just like to take your code and attach it conceptually to the bucket. That's what Lambda lets you do. So the original image comes in through an S3 put, gets stored in the Amazon S3 bucket, and then an event is triggered and sent to Lambda. This runs your thumbnailing code, which with a few lines of code can take that image and reduce it or convert it to different form factors, and then write it back to that bucket or to a different bucket. And so with a very small amount of effort, you can create this highly scalable, fully fault-tolerant, highly resilient responder that can be attached to that S3 bucket. And they can do the same type of treatment, the same type of reaction or response to any type of object that's being stored. So thumbnailing images or processing, auditing when files come in, or kicking off workflows, anything that you can store in S3 can now have an event handler associated with it. Similarly, with Amazon DynamoDB, our NoSQL data store, we've got a new capability currently in preview called Streams, which allows you to attach code or other types of responders to changes that are happening in a Dynamo table. So every time you update the content of that table, say you write another row or you delete an item in the Dynamo table, you can now run some code in reaction. So you can use this in combination with Lambda to do things like creating copies of that table perhaps in another region, or filtering the data, or maybe sending yourself a notification if you detect a row in there that might not contain something that you like. So lots of ways that you can now respond to the data that's flowing into that data store without having to set up your own fleet of machines to do so. And since we had Lambda in preview over the course of the first few months after that November launch, we've seen a number of different companies build really interesting and exciting things with this capability. Companies like Comply, that's doing their real-time processing for social media traffic and using Lambda to do computation and analysis over those data streams. Companies like FireEye that are using Lambda's high scalability and parallelization in order to do really rapid search across blog content. NativeX is doing something similar for their prediction analytics, where they're using Lambda to process logs, and they can run a Lambda function every time a log comes in, whether it's a few logs a second or thousands or tens of thousands every minute. So lots of different companies getting all kinds of amazing value. And now that we've moved Lambda to general availability, they're able to do full-scale production workloads. Now, the latest thing that we've brought out for Lambda, and we announced in the San Francisco Summit a few weeks back, is what we call mobile compute. It's the use of Lambda to create backends that can respond and provide that server-side code for mobile, tablet, and IoT applications. And to Lambda's existing event capabilities, we added three things: support for request and response or remote procedure calls, included Lambda in the AWS Mobile SDK, and then added some really easy personalization features. And I'll tell you a little more about how we make that work for both devices and end users. Request response was the extension to the Lambda platform that makes mobile compute possible. And what we've added here to our core support for asynchronous events is a synchronous request response so that you can call to Lambda and retrieve information from the cloud. That could be something like getting the current weather given the geolocation of the device that you're making the call from, or retrieving data from a database and then doing various kinds of transforms to it, or making a call to other web services and then perhaps integrating or consolidating that information before you send it back to the device. And with this, you can create these instantly scalable backends for your mobile apps, so that without even understanding in detail how to create fault-tolerant or highly scalable systems, you can rely on Lambda to provide all of that infrastructure capability and all of that scale and fault tolerance for you around the world, and you just concentrate on writing your code. And we'll talk a little bit in here about how you can use Lambda in a very flexible way, but one of the nice things about this is that you can also bring your own libraries. So if you've got, say, C or C++ libraries that you need to build a backend for an IoT device, you can actually bring those along and get a compatible experience on the server as well as on the client. Now, part of making this available for mobile developers means having it be present in the different scenarios that mobile developers need to work. And so we've included support for Lambda in the Mobile SDK for Android, as well as the AWS iOS Mobile SDK. So previously, you could access Lambda through any of our conventional SDKs. Now we've made it possible to do it from the mobile SDKs as well. And then if you're using Android Studio or Eclipse, Sublime, or another IDE, you have a really easy integration path there to install the mobile SDK libraries and then get rolling. And we'll actually take a look at this in the demo in a few minutes. Now, one of the most exciting things about the addition of the mobile compute support is making things easier for application developers. And there are two questions we always hear mobile devs trying to answer, in addition, of course, to wanting things to be easier to build on the back end. First question is, which end user am I working with? Not which app do I have, but who's actually holding the phone? And we've added support for cognito identity. Cognito is our mechanism for allowing users to authenticate, for example, using OAuth with Facebook or Twitter or Amazon Identity. And we take that information now with Lambda and we pass that directly through to the Lambda function, so that inside your function, you've got all the information you need to understand who's in the other end of that connection. And then you can take that information and use it to build either search strings or to customize the response, or take whatever steps you need to personalize that based on the user. The other question, of course, is always which application and device is the user using? What kind of hardware, what kind of form factor? Because if you're returning an image or some other type of asset, you may need to know what kind of machine to customize that for. So we also provide information that we can glean from the client-side device and the hardware, and can tell you things like the make and model so that you can return the right kind of media assets when you make that response. So not only can you make the request and response really easy and scalable, but you've got all this information at your fingertips to customize the information. All right, we're going to take a pause here from the slide deck and turn in and look at an actual demo here. So I want to start with the AWS console experience for AWS Lambda. And what you're seeing now on your screens, hopefully, is a picture of what we call the Lambda function list. So this is sort of your primary landing spot on the AWS console and gives you insight into all the different functions you have. We've also put some information at your fingertips here, like the CloudWatch metrics. So we provide free built-in metrics for the basic experience that you're getting with each of these functions to help you understand how it's responding. And you can see here that I've made a couple of calls to this function in the last few hours. And then we can also get a sense of how long those functions ran for. Fortunately, didn't have any failures, and I wasn't throttled at all. So it gives me a quick dashboard type view of what's going on with that function. It also lets me quickly step into the function and take action on it. And I could do things here like hook that up to an event source like S3 or Dynamo. But what we're going to do here today for the demo is going to click on Edit and Test, and we'll take a look at the interactive experience. So one of the things we've built into the Lambda console here is the opportunity to actually edit and test your code right from a browser. So what you're seeing here is a really simple piece of code. I'm going to highlight the line here called context.done. What this is doing is basically taking the event that was sent to Lambda and it's returning it back again. Then I have a few logging statements which are showing me what the event is and also what that context variable is. And that context variable is where you would find that personalization information, such as the identity or the device information. Now this code is super simple. Mostly this is just an echo routine. However, I'm making one change. I'm actually sort of rewriting the name that's going to be coming in here. So you'll see my test event over here on the left-hand side in what's called sample event. I'm passing in essentially a JSON object with two fields, first name and last name. And I've just set up the sample data here to be my own name. And then the code is going to return the last name, but it's always going to change the first name to Bob. This is a really simple, silly example, but it illustrates some of the power of what you can do on the server. For example, this could be a field that we retrieved from a Dynamo database and then did some post-processing on before returning it back to our client. Or the payload in could have been, say, the geolocation of the device that was making the call, and the information that we could be returning here might be, for example, the weather in that location along with whatever the closest city was. So this gives you a sense of how we can build the backend in the cloud, and then how we can send it to sample events to see what happens. So let's go ahead and do that. I'm going to click on this blue invoke button, and it's going to actually send that test data, which has my name in it. And I'll scroll down here and we'll take a look at the result. So here you can see the function executing. Fortunately, it did what I just described. Instead of returning Tim Wagner, it to return Bob Wagner. So we saw it take that input payload and make a simple change to it and send it back. You can also see underneath this a summary of what happened in that request. So along with the request identification, you can see the duration, how long it took, how long we were billed for. That was 100 milliseconds. And then how much memory was initially requested by the user and how much memory was actually used. So this information helps you configure future calls of your function. Maybe you've asked for more memory than you need and you can actually turn it down to save money. Or maybe your function's running longer than you expected and this gives you some insight. Over on the right-hand side, you can see the execution logs. And so you can see a copy of the event payload that was coming in, and then also a copy of the context variable and the result. Now these logs are also available for you in CloudWatch. One of the nice things about Lambda is that not only does it automatically monitor, it automatically logs. So I'll take a quick side trip here and show you the CloudWatch log console as well. And we'll take a look here at the log stream from a previous request that I made. And you can see the same kind of information being shown over here. I can also take a look at different log streams, for example, peruse some of the requests that I've made in the past. Here's an example that I made from a device, and you can see some of that actual information where I'm seeing, for example, a call made from a specific Android device. This was actually an emulator, and then also some information about that Cognito ID. So this is how that information will show up to the function and allow it to be used. Now let's hop back to the Lambda console here. So we finished doing our edit and test cycle here. We've written the code, we have the function going, and we validated that the backend is now doing what we expect it to do. And we were able to do all of that from a browser without actually any client-side work. And I'll show you one more thing real quick before we leave the console. Here under advanced settings, if I wanted to go change the memory or the duration limit for that function, that's where I could make those changes. So that information that we provide about how that function was executing can be used here to change those settings for future calls. Now, having written the server side here, we could go use this function, maybe hook it up to various event sources, but let's take a look at that mobile compute example. I'm going to come down now and open up the Android Studio. So this is just the normal Android Studio, and I've got a really simple client application in here that's going to make use of this back end. So first, let's take a look at the data model. Here's essentially in Java now what we just looked at in that sample event on the console, where we've got a class name info that has a first name and a last name component to it. And what's interesting about this file is really what isn't in it. This is just a normal POJO. So there's nothing in here at all about Lambda. It's a nice, clean data model that doesn't require you to change anything about your business objects in order to integrate. Now let's take a look at the remote function. So in this file, we're defining an interface that represents the remote procedure call. So this echo routine is that backend that we just wrote. It's that echo function that you saw operating in the console just now. And this is the representation on the Android client side of making a call to that echo routine. And again, you'll notice there's very little here that has to be done to make this work. Basically, we define that routine in a normal way that's idiomatic for Java, and then we annotate it with @Lambda function. And this is going to be the indication to the system that we need to serialize and deserialize that information across the wire. Finally now, let me hop over here to the code where the real work is going on and show you how easy it is to hook this up to the Android application. There are basically 3 lines here at the end of this file as part of the onCreate method that are responsible for setting up the Lambda invocation. I made creating an invoker factory and then a specific invoker, and then this is what's going to allow me to make those remote procedure calls. And this is the whole essence of the integration here. Everything else, it just looks like a normal function call. Once I've got this, I can now send POJOs across the wire, and they're going to get serialized by the built-in Lambda JSON binder. And even this isn't required. If you want to do your own binding, you are more than welcome to do that, and you can send information across to Lambda at the level of byte streams as well. And then finally, we'll scroll up here and we'll take a look at the actual call. And on the highlighted line here in blue, you can see invoker.echo being called, passing in a name info, and then getting a name info back in return. And I'm going to hop over here to the right side of my screen to the emulator, and we'll go ahead and see if we can enter my name. And we'll just repeat that test call that we made on the server side, now from the client here running inside of the emulator, making a call to the back end, and if the emulator is going to behave, there we go. So we've seen a round trip response here that made a call to the real Lambda function. And the nice thing about this is, let's say this app, silly as it is, suddenly got popular, and we had 10,000 different requests all being made to it simultaneously. We wouldn't have to change a single line of code. What we wrote on the server side, even though it was just a few lines of simple code, is now being managed, scaled, and automatically deployed to as many pieces of machinery as necessary by Lambda. And so we saw one simple test call here. It's the same call, the same experience that you'd have running that code at massive production level. Alrighty, this is the end of the demo portion here. Now I'm going to switch back and take us to the slide deck again. Let's talk a little bit about what we saw happening in that demo. So what was going on with Lambda that made that experience possible? Well, first and foremost, and if you remember nothing else about Lambda, take this part away, that there's no infrastructure to manage. The thing that made this so quick and easy for us to do in the space of just a few minutes there is the fact that we were able to focus on writing business logic that was free of any description about capacity, scaling, provisioning, deployment, monitoring, logging. All of that was built into the experience. So all we had to write was the actual logic that wanted to process the name info, the first and last name parcels that were coming through. None of these other pieces, like getting a web service up and running or figuring out how many machines to put it on, or then how to keep it security patched over time. The other part that worked well, even though we saw this for a single request, is the automatic scaling. So the fact that we didn't have to think about having either too much or too little infrastructure to run the number of requests that were being made. Because Lambda scales automatically to match the event rate. The more requests you make, the more capacity it allocates. The fewer requests you make, the less capacity it allocates. So as a result, as a developer, you never worry about over or under provisioning, and you only pay for what you use. No matter where you're at in that app development lifecycle, from development to deployment to full-scale successful production, you've got a matching set of infrastructure and capacity that Lambda is providing. Now, we did a simple example in this demo just here where we wrote in pure JavaScript. But this isn't always the case. Sometimes you've got a library that you want to bring along, and that library might not have been written in JavaScript. In fact, it might have arbitrary native code in it. And then once you're working inside that code, you might need to do things like write to a file system or create processes, start multiple threads. We have a tenet with Lambda when we designed it that said you have to be able to bring your own code. You have to be able to use the libraries, the routines, the capabilities that are important to get your job done. We can't possibly curate the rich set and variety of all the different things that people need to be able to run in the cloud and to build event responders, mobile backends, and all the other great things that they want to run on Lambda. And so instead, we've designed this with a security model that lets you bring the code you need and run it on the system, whether it's writing to the file system, creating background processes, running bash jobs, all of that is possible. Now, if you were paying attention during that demo, you might have noticed that the duration pricing was actually listed in milliseconds, and that was no mistake. Given that we want to run code in response to requests, sometimes relatively short-lived requests, it's important that we be able to actually price Lambda in equivalent terms. And so we actually charge at the level of 100 milliseconds for our compute. And there's also a low request charge. This allows you to factor your compute any way you want. You don't have to think about trying to batch it up. You don't have to worry about whether your request ran for a short time or a long time. Regardless of how you do it, we've got a pricing model that matches here. There are no monthly, daily, or hourly minimums to pay, and there are no per device fees. So whether you're testing this on one device or you're running it in production on devices all over the planet, there's no special or hidden fee as a result. And then we've provided a very generous free tier. So every month, every customer gets 1 million free requests and 400,000 gigabyte seconds of compute time. That gives you enough room to be able to develop apps, work as a small team, and not worry about the costs of using Lambda as your solution for compute. Then when your app gets big in production, you never have to worry about paying for idle. So whether your app is experiencing a heavy day or a light day, the cost is always matched to the exact amount of work you're doing. Now let's switch gears a little bit and talk about how you actually use Lambda and how the programming model works. Lambda functions can get called in a variety of ways. We saw in our demo the use of building it as and using it as a mobile backend. So you have mobile apps or web apps, including client-side JavaScript that can call in. And the inclusion of support for Lambda in the AWS SDK and the mobile SDK allows you to make those calls from a variety of languages, Java, Ruby, Python, as well as from the command line or directly against our REST API. So very, very flexible and broad variety of ways in which you can call into the Lambda APIs. Now, we didn't look at it in this demo, but you can take a look at the reInvent YouTube video where we announced Lambda. And in that breakout session, we have a demonstration of hooking up Lambda to Amazon S3, such that every time an image is uploaded, a thumbnail is automatically created in that same bucket. So you can also send these events from S3 or from SNS. And for all of those approaches, all of those sources, every time you send an event, we'll try up to 3 times to get your code to work. Now, of course, we expect that primarily managing that code yourself, catching exceptions that you want, deciding whether or not your code succeeded or failed. But sometimes something happens or there's a transient error where it was unanticipated, so we will automatically retry twice after that initial attempt. Well, there's another category of event sources where Lambda is actually doing the polling for you. This includes DynamoDB changes as well as Amazon Kinesis record streams. And in both of these cases, Lambda is going to reach out to those event sources and retrieve the next set of events and present them to your function. Now, this is different in a few different ways. First of all, it's an ordered model in this case. If you imagine the Dynamo example, an insert followed by a delete is very different than a delete followed by an insert. So we have to keep those records in order. We also allow you to batch them up in a customized way. And then in order to preserve that sequencing, we will keep retrying until the data expires so that your code can always process those records in order. And then finally, for all of these different ways of calling Lambda, we've got a safety limit of 100 concurrent executions. Think of that as 100 parallel uses of a Lambda function and 1,000 invokes per second. But these are just safety limits. You could think of them as like the training wheels that you get by default, And then when you're ready to take them off and go big, you just send an email to our customer service team and we'll raise those limits for you, because Lambda itself is designed to scale up and out as far as you need to go. And this is in there just to make sure that you aren't running more functions than perhaps you initially intended to. Let's talk about how you write Lambda functions. So start off here with the basics. The language that we have support for today is Node.js, and it's a completely stock version of Node.js. There's nothing special or magical or different about our version of it. We just take a normal version of Node and we run it inside Lambda and make it available for you. We also pre-install the AWS SDK so that from inside your Lambda routines, it's really easy to do things like write to an S3 bucket or put data back into Dynamo or call any other AWS SDK API that you'd like to. We also handle all of your inbound traffic. So you don't need to have a web server. In fact, we don't want you to have a web server. You just write your code to respond to those requests as they arrive. And then you can make, of course, as many outbound socket connections as you like. Now, the programming model is what we call stateless, and we really mean two things by that. First of all, there's no storage model associated with Lambda itself. So Lambda doesn't keep your data around. Instead, you use S3, Dynamo, or any other internet storage mechanism that you want if you need to have persistent data. In our simple demo, we were just doing a round trip. There was no data to store. But if we had wanted to retrieve information from, say, Dynamo or from S3, we would simply have reached out and grabbed that information on demand. And then Lambda will reuse your container in many cases, allowing you to get effectively a local cache of that information. Now, the second piece of statelessness here is that there's no affinity to a particular piece of hardware. Or, as people like to say, you can't log into the box. So every time you request, we will find a place to run your code in a way that is efficient and low latency. But we don't give you a particular box in a model where you hold on to that for a long period of time, because we might need to change where that hardware is running. This also allows us to keep those machines up to date, perform security patching, and take care of all that background maintenance. Now, that said, everything else about the programming model is familiar. You can use processes, threads, you can write to /temp, you can open sockets, you can do all of the things that you're used to doing in your code. You can even run background executables, and you can run them in other languages. Now, we took a look at an existing Lambda function, but creating one is just as easy. You basically have to pick a name, you have to pick a size, and we ask for that in terms of memory. So once you tell us how much memory you want, we figure out how to give your function an equivalent percentage of other resources, such as disk or network bandwidth. That gives you a simple single dial to decide where you want to set your price performance ratio. And then, as you saw in the console, we also tell you every time you run a function in the log how much memory you used and how long it ran for, so you can tune those settings over time. And then if you want to be able to use that Lambda function to respond to an S3 bucket or Kinesis records or some other kind of change, then you pick an event source and you just tell us which event source to hook it up to. And within a few seconds, you're up and running, and that event source is sending events automatically to Lambda. Now, one of the questions we get a lot is, hey, AWS now has like this whole variety of compute offerings. How do I know which one I want? There's Lambda, there's EC2, there's the new EC2 container service. How are they the same and how are they different? And how do I know which one's right for my scenario? So let's take a look at a few dimensions here that help you pick. Probably the most important one here is how do you want to approach your compute? As we talked about, and as you saw us demonstrate, Lambda's request driven. So if you want your code to run in response to remote calls that you make or in response to changes that you're doing in terms of, say, an S3 bucket, Lambda is a really easy way to do that, because all the work of figuring out that connectivity and then managing the scale and the underlying infrastructure is done for you. EC2 and ECS you should think of as an infrastructure rental model, and you decide how much you want and when you want it. So a little bit like the difference between staying in a hotel versus renting an apartment. Now, Lambda prioritizes ease of use, and as a result, it makes a whole bunch of choices for you, right? Everything runs on Amazon Linux. There's a default hardware choice. Amazon EC2 and the container service are much more flexible. So they give you a lot of choices. For example, if you need to pick a specific different kind of operating system, if you need to change the instance type, maybe to optimize for memory or disk, you get a lot of flexibility and a lot of choices there when you work at that level. That also means that you own and configure that infrastructure versus Lambda, where AWS is owning and managing all of that infrastructure on your behalf, including doing things like security patches to the operating system. And then finally, sort of an artifact of the request-driven nature is that when you're using Lambda, scaling is implicit. So you don't have to think about asking for more Lambda. You don't have to tell Lambda to provision for you. You just make requests, and Lambda figures out how much capacity needs to be applied. Now I want to turn and talk a little bit about some of the new features that we launched this month. And two of the most exciting ones, and you'll see us continue to do this trend line, are about attaching more and more AWS services to Lambda. So these new AWS event sources in April included the SNS, or Simple Notification Service. And if you haven't used SNS before, this is our messaging service. It's a pub subsystem that allows you to publish messages and then send them to a whole variety of different places, including mobile, endpoints, and now also including Lambda functions. One of the exciting things about attaching Lambda to SNS is that SNS is broadly used as a messaging and communication mechanism. And now every service that uses SNS, every service that can send messages, automatically gets support for compute. So any of those messages can now be turned into triggers that run arbitrary code. So for instance, if you were using Amazon CloudWatch to send yourself alarms, for example, when your EC2 instances needed to be scaled, or some other metric was changing there, now you can use a Lambda function to programmatically take action whenever that happens. Very simple, and the fact that there's no infrastructure involved makes it really fast and easy to do that. You can also use Lambda to customize SNS messages as they flow through the system, and we'll talk about that in a second here. The other service that now can send events to Lambda is Cognito. So you heard about Cognito earlier in this webinar, where we talked about getting identity information into a function that can help you personalize how that function works. But Cognito's got another capability too that we call Cognito Sync. And what that does is allows you to easily synchronize user data across devices. So for instance, if a user's playing a game, the level that they're at or other pieces of their game state can be transparently synchronized across all their different devices. So whether they're using the phone or maybe they move over to a Fire tablet, they can pick up right where they left off in that game. Now you can take action whenever that data changes. Every time that those data values get modified, Cognito Sync now informs Lambda so that you can run arbitrary code in the cloud. So you could, for instance, now notice that if the user's made it to a new level, you might want to send them an advertisement for an in-app purchase, or grant them an achievement, or take other steps that you can do from a back end. So one of the exciting things is we keep adding more and more AWS services that can send events to Lambda is how easy it's becoming to put together really exciting end user scenarios. So for example, suppose you want to send customized messages to different users, and you need to go use Dynamo or some other database table to look up which messages to send to which users, or how to run an A/B test to customize different demographics. Now with SNS and Lambda, you can easily do that because you can insert Lambda, trigger it off a message, and then turn that message around and customize it in different ways depending on the data lookup that you've done or the content of the message. You might want to send an offer to a user when they run out of lives in their game. Now with Cognito and Lambda, and using SNS as a messaging system for mobile endpoints, you can quickly snap together those three different systems and create a targeted notification mechanism that can use arbitrary logic to make that determination. Or perhaps you've got an IoT device, a hardware device like a smart thermostat in your home, and you'd like to be able to send that data up to the cloud and then take action whenever that data goes above or below a particular threshold. Using Kinesis as an event source plus Lambda to provide that filtering and response allows you to trigger anything you like. And because we've built in the AWS SDK, you can store that result or that information in a database. You can go notify somebody about it. You can take any step that you like calling anything within AWS or any other public internet endpoint. Now, a few other features that we rolled out this month. Cross-account access support. This was something that we had a lot of requests from customers during the preview period who wanted to be able to send events from S3 buckets where the owner of the bucket might not be the same as the owner of the Lambda function. And so we got one step further here. We actually opened this up for all users of Lambda so that a Lambda function owner can now decide which accounts to grant access to. Makes it really easy to do a whole variety of third-party enablement scenarios. We also added support to Lambda for CloudTrail integration. And if you haven't used CloudTrail before, this is an auditing service that tracks all of the API calls across all of the AWS services and enables you to get a log of those and store it in S3. And now you can actually do really cool things with Lambda because you can process those log files with a Lambda function, allowing you to take action when, for example, a specific user has done something like created an SQS queue, and you want to respond to that either through a notification or tracking it somehow, or maybe even deciding to take some action to sort of reverse or disallow that step. So a really powerful mechanism for auditing that's now fully integrated with Lambda. And the CloudFormation team also added support for using Lambda functions as custom resources. So if you're using CloudFormation to stand up stacks of AWS resources, now anytime you create, update, or delete those stacks, you can run arbitrary logic on Lambda without having to do any infrastructure or provisioning to help complete that setup. Really powerful and simple mechanism that makes the best use of Lambda's capabilities. One of the things we always hear from customers, and it's sort of part and parcel of trying to make things simple, is that we need to also make errors or problems discoverable. So if you have a function, that function isn't behaving right, maybe it's running slow or it's not performing the way you want it to perform functionally, how do you understand that with Lambda and how do you go take action on it? So those metrics that you saw on the dashboard give you real-time insight into how your functions are behaving. So Lambda will automatically monitor all of your functions. You'll see the results of those on the Lambda dashboard as well as within the CloudWatch dashboard, and you get free metrics for requests, number of errors, the running time of your functions, and we've just recently added a concurrent request throttle metric. This latter one is really helpful to know whether or not it's time to go make that call to customer service and ask them to take training wheels off. Then the other piece of it is the logging one. So Lambda will automatically log all of the invocations of your function, even if you don't write any log actions into your actual function yourself, which of course you're welcome to do so, and you saw some of those being done in the demo. And then CloudWatch Logs has recently added some features like being able to sort by the time of last entry that make it really fast to find the relevant logs as you're doing debugging and development scenarios, or if you know that you had a recent problem and you're trying to sort through the logs to figure out what happened. We've also added the creation time to the log stream names to make it really easy to filter, and also provided the name of the log stream into the Lambda function so that you can correlate what's happening in your code with what's getting stored in the logs for later discovery and analysis. And now I want to talk about something that's coming soon. So everything you've heard up to now is available in full production and ready to go today. And we've got one pre-announcement that we made a couple of weeks back about Java. And let me first say that if you're interested in using Java, you don't have to wait. Java and other languages are included in the file system that you get on Lambda automatically. So you can fire up a JVM from your node code and you can use Java today. And you also don't have to worry if you want a long-running Java process. You can actually keep that running and we will reuse your container. And when we do so, we'll actually freeze and thaw your JVM so that we can avoid that reinitialization process. So we actually have already a fairly sophisticated treatment for Java, Bash, and other languages that you can use without doing any modification or extension of Lambda today. But we're going to make this even easier. Within the next few weeks, we'll be releasing built-in support for Lambda functions written in Java. So you don't need even that 1 or 2 lines of node code to get going at the beginning. You'll be able to start up a Java function directly as a Lambda function. And that same POJO serialization magic that we saw on the Android client will also be available to Java functions. So we'll make it really easy to work in Java in any of 3 ways. At the byte stream level, if you want to do your own marshalling and management, at the JSON level if you prefer to work in documents, or idiomatically in Java with POJOs directly. And you'll be able to choose any of those as you work in the Java language. So look for that in the coming weeks. 3 things you can do to get started with Lambda. First and foremost, go recreate that simple demo experience that I showed you on the console. In less than 2 minutes, you can have a Lambda function written and running and get a first-hand taste of what it's like to create a function in the cloud and just how quick and easy that is yourself. And you can click that invoke button up to 1 million times a month for free. So it's really cheap and easy to get started here. The next thing you can do is take that function and hook it up to your favorite data source in AWS, S3, DynamoDB, SNS, Kinesis. Without building any other infrastructure, you can start responding to changes in those resources. For example, items being added to an S3 bucket. And you can use your Lambda function to respond to them. Start with something simple like a console log just to see that it's working, and then progress to making changes or updating those objects as they flow in. Really easy to get started there. And then finally, you can do the same thing I did on the client side and create your own mobile app that calls into Lambda as its backend. And you saw how few lines of code were necessary to get that fully integrated and working with just a stock Android app experience. If you go to the Mobile SDK on our website, we actually have a walkthrough that'll recreate that experience you saw me do in kind of a step-by-step fashion so you can get it in recipe form. Thanks so much, and I've included a few links in here to our website, to the AWS Compute blog, where we provide ongoing updates and information about Lambda, as well as the Lambda forums, where you can learn more and get started using Lambda.